thing that we're going to be talking about is we are going to be talking about covalent bonds. So we just talked about ionic bonds. Just as a quick review, ionic bonds are when we're transferring electrons. So one is giving and one is stealing it. And it's causing a positive and a negative charge. And so then they're attracted by those positive and negative charges. All right. And then there's various properties that you need to know. So for covalent bonding, we're not gonna go through that many slides, so watch the whole video, okay? It's gonna be about like maybe 7 slides or something. So make sure you watch the whole video, but it's gonna be lots of information. So take really good notes. So let's start on this slide and talk about what they actually are. So covalent bonds, they're when elements share electrons. So then they're bonded together because they're sharing those electrons. So instead of ionic bonds where one is taking and one is giving, they're going to share the electrons to be able to get to 8. So if I have one with 7 that's sharing with one that has 1, then if they add their electrons together, that equals 8, and they can bond together. All right, important thing about covalent bonds is that it's only between nonmetals. So it's only between elements over here and hydrogen, anything in the blue. That's the only things that bond together in covalent bonds. And so on your test, it might ask you questions like, if you have like an element that has O bonded with H, what is that? And so if you know that O and H are the two things that are being bonded, you know it's covalent because they're only nonmetals. If it asks you if it's between Li and Cl, you know it's going to be ionic because it's a metal and a nonmetal. So those are just some important things to kind of keep in mind during the test so you can remember. All right, here is a visual of our bonding. So we see with covalent bond, we have Cl and we have H. They're both nonmetals. This H has 1 electron, this Cl has 7. And so they want to come together so they both have full outer shells. So here you can see that they are both going to just share those electrons. So now we can count, and Cl has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons, and H has 2, which remember H is happy when it has 2. So they're able to be sharing those. So now we're going to look at some Lewis structures. We talk about these in class. You can see that H has the 1, Cl also has the 1, and then they're going to be bonded together in this line. So when we do Lewis dot structures, if it has a line in it, that's showing that Cl and H are both sharing 1 electron. So that is kind of a visual representation. Depending on how much in-person school we're going to have and stuff like that, we might learn more about Lewis dots and do more of these drawings where we have to draw with lines and dots. But for right now, don't worry too much about it. This is just so you can visually see what's happening with Lewis dots. So covalent bonds, there's some properties of them. Again, remember, these properties are really important that you know, because on your test, there's going to be several questions that ask you about if it has this property, is it covalent or is it ionic? So covalent is kind of the opposite of ionic. So they have a really low melting point. They're usually going to be a liquid or a gas at room temperature. An example of a covalent bond is water, H2O, and so that is a liquid at room temperature. Another thing is that it does not conduct electricity. And the final thing is that it is low solubility, so it does not dissolve in water. So there are some exceptions to that, things that do dissolve in water, but most of the time it won't dissolve in water. So again, you can run certain tests to see, if it melts at a really high temperature, it's going to be ionic. If it melts at a low temperature, it's going to be covalent. If it doesn't conduct electricity, it's going to be covalent. And if it's a low solubility, if it's not going to dissolve in water, it's going to be covalent. So here's another thing that you're going to need to know, diatomic molecules. And so there are certain molecules that covalently bond and they're 2 of the same element. So instead of being H2O where they're different elements, there are ones that combine that are the same one. So the diatomic molecules that we have are H2, N2, F2, Cl2, Br2, and I2. And you need to know these. We'll review it some more, but make sure you know them. If you go to a periodic table, you'll notice that, H is up in this corner, but then the N and the FClBri, they're all kind of over here on this side. So they follow a pattern. So if you look at your periodic table, you can probably know which ones are diatomic molecules pretty easy. This is just an example, another Lewis dot structure of it. So you see F we have F2 here. So this one has the 7 black dots, this one has the 7 red dots. If they come together and share these two, then they both have 8 around them and they're happy. In the loose dot structure, we can show it this way with that line in the middle to say that they are sharing electrons. All right, so with covalent bonding, there's 2 different kinds of molecules that you can have. You can have polar or you can have nonpolar. You might have heard these terms before. So when we're talking about this, we need to know that this first bullet point, that there are some elements that want electrons more than others. So there can be unequal sharing. So there are some, right, that are more electronegative, that are going to pull electrons harder when they're sharing. They're not going to pull it as hard as taking it completely off, like with an NaCl, where it's ionic and it pulls it completely off, but they're going to pull the electrons really close to them and far away from the other one. And because they do it, it creates some partial charges on the ions. So one side is going to have the electron closer to it more of the time, and so it's going to have a partial negative sign. The other one is going to have electrons near it part of the time, and it's going to have a partial positive sign, because they're not going to be there as much. Remember, electrons are negative. So our 2 terms here are polar molecules are ones that have unequal sharing. So that's when one's pulling harder than the other one. Nonpolar molecules are when there's about equal sharing. So they're sharing the electron equally, it's in the middle, it's not closer to one or the other. So those are the 2 terms that you need to know. So remember, pause and rewrite any of the slides that you need to, or go back and listen to me talking about them if you need. But we're going to move on to some example pictures because that's going to be easier for you to understand these concepts. So make sure you have the definitions down. All right, here we go. So these are some visuals. So nonpolar and polar. So in nonpolar, you can see that we have I, and they're both going to hold these electrons about as close to each other. There's not going to be one that's holding it way closer than the other, right? And so they're not going to have any charges on them. You can see here that they both are holding their electrons about the same distance. They're just bonded in the middle. You'll also know that I, they're right here on your periodic table. They both want the electrons about the same amount. So it's like following those trends that we talked about last unit. I both want the electrons the same amount, so that's why it's nonpolar. You can tell by looking at your periodic table if something's going to be polar or not polar. Usually if it's the same element, they're going to want electrons the same, so it's going to be nonpolar. If it's 2 different elements, there might be some unequal sharing. So let's look at this one, this polar one. So you have O right here, and you have H right here. You can notice that the O, these electrons are a lot closer to the O than to the H. You know that O is over here on your periodic table, and so elements over here, remember, they really want those electrons, so they're going to pull them really close to them. Usually if you have an O, F, Cl, like these kind of elements over here are usually going to be polar molecules, especially if bonded with H. H is way over here. So that's going to pull it really close, and it's going to make it be partially negative and partially positive. You can tell that it does this symbol here. That stands for partial negative, and that stands for partial positive. So when you draw things, you can show people that this is partially negative and that's partially positive by doing that symbol. This colored one I kind of like too because it shows us that this O has a lot more of the electrons that stay by it, and this H has fewer electrons that are staying by it. All right, hopefully this kind of helps. This might be a subject that you need to go like email me with questions or stuff like that. We'll look at some practice problems later. But we'll move on to our next kind of bonding. This one is just one slide. So it's called metallic bonds. And we've been talking about between, metals and nonmetals or between just nonmetals. So metallic bonds are between just metals. And it's basically the sea of electrons that float in between the elements. And so that's why metals are usually really good conductors because the electrons are floating carrying all that energy. But that's all you need to know about metallic bonds, nothing too crazy. So thanks for watching this, you guys. Make sure that you do your work over distance learning. These videos and the assignment is going to be pretty much the only thing you're going to need to do between now and Thanksgiving. And then we're going to have some naming practice. And naming is really hard. And so it's really important that you try to watch the videos and try to do your homework before you come to class. And then when you come to class, we can ask questions about it and figure it out. Like I said, this unit, we can start doing some experiments, and I really want to be able to do those in class. But if we have to review this whole PowerPoint again, then we can't do those experiments. So it's really important that you stay on top of your work, okay? I'm going to post another video that's going to have help with the homework, because I know sometimes I do the lectures and you guys look at the homework and you don't know how to connect the lecture with the problems on the homework. So watch for that video if you need help on the homework, and I'll kind of go through how to do each problem. All right, please email me with questions. Have a wonderful Thanksgiving, and remember to keep checking Canvas for any of the work, okay? Email me with any questions you have.